Alright guys, this problem is one of the most annoying problems, not because it's physics, it's always hard, but because it's words physics, so you need to read the whole thing. And the funny thing about this is that some of the stuff they gave us, the information they gave us, we don't even need them. Alright, let's go through it. Let's do ground crew physics. I'll put the question. I'm not going to read the question. I'm going to put the question in the description below. So guys, just read it and then see if it's the same question that you guys have. So the first thing they asked us was determine the average angular acceleration during the 1.08 spin up. Okay. So let's look at what they gave us in the question. They gave us the mass, and they gave us the time while it was accelerating. So accelerating time. And then they gave us 4.4 revolution. That's the final speed after the time they gave us to accelerate to the fully, which was 4.4 revolution per second. Okay. And what else they gave us? They gave us the time that it's decelerate. Yeah. Decelerate. It was decelerating time. So these are the information that they gave us. The mass, we're not going to use it in anything throughout this equation. So let's go to the first one. That was determine the average angular acceleration during 1.08 spin up. Alright, so since they gave us 4.4 revolution per second, we need to change that to radian. So 0.4 revolution per second. Please guys, tell me you know how to convert that to radian. That will be a disaster if not. Anyway, so revolution is equal to 2 pi radian. Okay. Then you just cancel those, and then after that you get the W final we were looking for. Okay. So in the question they're asking about the angular acceleration. Okay, we're not done yet. They're just asking about the acceleration. So I'm gonna use this equation equal I plus AT. Okay. So it starts from rest. So this is going to 0, and then the W final, the omega final, will be the answer from this. So after you convert this, use it in here. So W final divided by the time. So this is going to be the time that's accelerating. So it's a positive one. Okay. So we do the same thing. Second question. Determine the average angular acceleration during 0.21. But now during the spin down, so now it's decelerating, so it's reducing in angular speed. Okay. Angular velocity or angular speed? I think it's velocity. Oh, it doesn't matter. Where we at? No. Yeah, we're talking about decelerating. So we do the same thing. W final, W initial, plus angular t. So now the W final, since it's decelerating, so it's going from full speed to 0, the final will be 0, and the initial will be the final from the question before. Okay, so that's why when you take it to the other side, it'll be negative Wi, and then equal acceleration t, then omega I negative t. Okay, don't forget the negative. They're not gonna accept that without the negative sign. I know. Cool. Let's go to number 3. They're asking what's the maximum angular speed reached by the flywheel. Well, we got that in the first question, right? That's what we got in here. So this question. And then the last one. Determine the ratio of number of revolution made during the spin up to the number made during spin down. All right. If you guys just looking to solve it really quick, the way to answer is just divide the the answer from number 2 divided by number 1, and you'll get your answer. And keep it positive because they're looking at the ratio. They don't care if it's negative or not. They're just looking at the ratio. So just divide the answer you got from question number 2 divided by 1, then you'll get the answer for that. But if you really want to look into it, we're looking for. So we're taking like the what's it called? The theta, the displacement theta, and then so omega pi squared I plus 2 theta. Okay. So this is for the first one. And then the other one. So use this equation. Sorry, I just zoned out for a second. I know. And then you just plug in the numbers for the other one, and then so theta accelerating will be equal to W final squared divided by 2 omega, 2 acceleration, then the theta decelerating is equal W final divided by 2. This one is accelerating and this one is decelerating. And then you just divide this. Wait, hold on. You spin up to the number. So you divide this one divided by this one. So this is on top and this is on the bottom. Okay, so it ending up revolution. This is gonna take up because they have the same one. This should be the initial one. Okay, so you're gonna divide those by this one on top on that. Decelerating and accelerating. And then you'll get your answer. Sorry, I zoned out in this one. I understand the concept, but it was a little bit hard to explain it. But anyway, guys, if you don't get it, I'm sorry. I tried. And hit me up if you need anything else. I'll see you guys.